Thank you for joining us today for Traits of a Prepared Engineering Graduate. You're going to hear Mark Mino talk about number 9 and number 10, dealing with communications. So listen, learn, and be deliberate about being a prepared graduate.
Hello, young minds. My name is Mark Mino. I'm the Engineering Director at Fleet Readiness Center East. Responsibilities include the aircraft engine and component engineers, our process engineers, and our materials lab, support equipment and test engineering design folks, our metrology engineering team, precision measurement center, our design engineers, etc. I graduated from Virginia Tech in 1994 with a chemical engineering degree. Came to work at Fleet Readiness Center at the time, NADEP Cherry Point, and have worked there for about 26 years. I wanted to take a couple minutes today to talk to you about the importance of your engineering curriculum and knowledge as it relates to being able to defend a technical decision once you graduate. It becomes a very important characteristic that engineers have, that they're expected to know everything about what they've learned. It's obviously not a realistic expectation, but now is the time for you to make sure that you don't let topics pass you by, that you grab mastery of all of the technical knowledge you need, and you also master the process of learning, so after you graduate, as technology changes, as new opportunities to learn come along, you seize those. Now in the education environment, you're around other students, some of whom have varying depths of knowledge on the subject you're currently learning. Graduate students, professors, office hours, you need to take advantage of all of that. Find extra resources to learn that information that you need as it works towards your curriculum. A lot of those topics build upon each other, and it's important for you to have mastery of that knowledge. Why? Because when you get out in the workplace, you're going to be expected to defend it technically. You need to be able to defend your technical decisions. However, you need to do it in a way that's understood. So a lot of times, contrasting the education environment to the work environment presents some issues for engineers. Here's a good example. In the classroom, let's say you're in a statics class or in an engineering design class, you're around other students that are learning the same material. It's kind of important for you to reflect to the professor and the other students around you how much you know. That's a good thing in the education environment. When you take a test or you write a paper or you write up a lab report, you're sharing everything you know about the topic. You're sounding smart. That's a good thing. When you get out in the workplace, you may very well be the only engineer hovered around a problem. Let's take a machine shop or a design activity. You're stuck on a design, the machine's having trouble translating the design information into a machinable process, and you might have the machinist, maybe a quality assurance specialist, maybe someone from the business office that planned the work, an engineer yourself, and others huddled around the problem. Here's where it becomes difficult. If you're ineffective at communicating in a way that can be understood by everybody, you will not be relied upon as an engineer in that environment. You need to be able to reflect what you're seeing with your engineering knowledge, but in a way that's understood by all that are around you. It doesn't really help at that point, like it did in the education environment, to try to sound smart, to use big words, to throw a bunch of formulas on the whiteboard as you're trying to work through it. However, you need to be able to demonstrate that you have enough grasp of the topic that you're a trusted person and a trusted individual in that problem. That's difficult. It's a sweet spot that you have to find. But to be a successful engineer as you get out post-education into the workplace, that's important. Even important if you go back into the education system. Your professors have to find that sweet spot, knowing that they might know more about the subject than you do, and figuring out a way to find the explanation area, that range that they can explain through the problem that's understood by everybody. So a very important characteristic and a skill to develop over time. So grab mastery of the knowledge, do everything you can to surround yourself and grab hold of all the information you can get a hold of, and then when you get out in the workplace, find a way to be effectively communicating as an engineer to all of the population. Blue collar, white collar, your superiors, your managers, others around you, in a way to be effective in your job. One more thing, your technical credibility, your content knowledge, which is the basis of your technical credibility, is going to be your ticket to long-term success, whether it's back into the education system or in the workplace, private or public sector, etc. You can't get that back. So now's the time to commit to continuous learning. Now's the time to commit to making sure you represent the information you know properly. Now's the time to make sure that you're an effective communicator, because your technical credibility is kind of a full pile. And if you cut into that pile, it's very difficult to add back into it. So make sure that your content knowledge, your ability to use all the facts you've learned to defend a position is not worn out or not decremented by your ineffective communications in the workplace. So again, best of luck to you. Good luck.